Today we're going to be talking about a game from the distant past which has not just lasted, but thrived through the years. A battle of skill and cunning where danger lurks around every corner. A game that takes minutes to learn, yet mastery is beyond mere mortals. Quake. At this point, the venerable 1996 shooter needs no introduction. But what if we were to combine it with this weird old board game? Well, that is exactly what the Impact team did way back in 1997. Quess is one of the earliest Quake mods, yet it is very well polished. Yes, this is classic chess implemented in Quake C, complete with 3 different boards, aka maps, and the full set of chess rules. The game adds Death Knight slaying, fiend eviscerating, shambler smashing action to the traditionally meditative game. The gameplay is reminiscent, although apparently not inspired by, the classic battle chess, only brought into the 3rd dimension. A glance through the readme suggests that it was written in a week, which makes it an even more impressive feat. According to Quess's archived website, it appears that a computer-controlled opponent, or AI, was in the works. Sadly, it seems this never saw the light of day. It is time to right this wrong. I am going to add a computer-controlled opponent to Quess. I won't be tackling this challenge by myself. I'll be standing on the shoulders of giants, using a selection of finely honed tools to build my bot. Let's get started. Quess programmer Ryan Ryder Feltrin was most likely writing his AI directly in Quake C, the language used to describe the game logic for Quake. I won't be doing this since the source code for Quess doesn't seem to be available. Here's how I will be doing it. When a multiplayer game of Quake, and by extension its mods, is played, users must connect to a server. This server runs the usual Quake executable, except it is started with some options which prevent the graphical front end from running. It also opens a port to allow connections over the network. Given the address, players can connect to the server. In this mode, the server handles all of the game logic, while the client is tasked only with rendering. The client sends commands such as movement inputs to the server, and the server sends back information about entities, centerprint messages, and so on, which the client duly renders. The server need not be separate. Quake can be started in listen mode, in which case there is a client and a server in the same process, but external players can connect. In fact, a normal single-player game has the same internal client and server, but with external connections disabled. My bot will act as a Quake client, connecting to an external Quake server running the Quess mod. Rather than display the game, the client will watch the entity positions and keep track of the chess game that is being played on the server. When it is the bot's turn, it will work out which move it wants to make, then send commands to click on the 2 squares representing this move. The bot doesn't have to be running on a separate computer, we can just run the script as a background process on the same machine, connecting to localhost. To interact with Quake, I'm going to use PyQuake, a Python library that I wrote. Given an IP and a port, it can connect to a Quake server. Once connected, the user can send movement commands, and observe the state of entities and other messages in the game, all wrapped up in a friendly async interface. So now we have a way for talking with a Quake server, but what about the other side? How am I going to get a Python script to understand how to play chess? For this I am going to be delegating to reigning computer chess ratings list champion, Stockfish. Despite its power, Stockfish has a very simple interface that reads board states and returns moves, both in a standard notation. Now I just need to mash these together. If I look at the positions of the Quake entities, I can convert them into chessboard positions, which I can then just plug into Stockfish, right? Sadly not. A chess game has hidden state that can't be read directly from the game. Not just the turn indicator, but also information about castling rights, en passant, and more. We'll be leaning on a third-party library, Python Chess, to resolve this predicament. Python Chess understands the rules of chess, and given a move, it can update an ongoing game. Even better, it is able to transform board states and moves into the standard format understood by Stockfish. Now we have all the pieces, let's take a step through a couple of moves in a game to see how the bot works. After connecting with the Quake client, the first thing we do is wait for a center print message that tells us that it is our turn. When we know it is our turn, we take a look at all the entities corresponding with chess pieces. Each entity has a field for model name, skin, and position. The model name tells us which piece the entity is, the skin tells us the colour of the piece, and the position tells us which square the piece is on. Given this, we can construct a partial board, which is a Python chess representation of the state of a game, but without any of the hidden state. We also make a full board object, initialized to chess's standard start position, which includes the hidden state. If, as in this case, the partial board differs from the full board, then we know that the other player has already made a move. Our full board is 1/2 move behind, so we can't plug it into Stockfish just yet. We can, however, use Python chess to loop through all the possible moves from this out-of-date full board. We tentatively apply each move and stop when we find the one that matches our partial board. Exactly one should match, so we update our full board. The full board is converted into standard notation, plugged into Stockfish, which, after working its magic, returns a move. Except for one special case, a move is just a start and an end square. In Quess, a move is played by clicking on these two squares in succession, which our bot does by working out the angles required to look at the squares, and sending these angles along with a click command for each to PyQuake. We update our full board with the move we just played, then go back to waiting for our turn. This process repeats until the game is over. We detect the move the other player played, get our move from Stockfish, then play the move, and wait for our turn. There are a few more details, such as how pawn promotion works. Working out the height of the board is also surprisingly tricky. And don't get me started on how netquake angles are so low resolution it is impossible to click on some squares without moving. But all in all, this project was fun, and a hell of a lot easier than writing the bot in Quake C. It is a testament to the open source world that libraries such as Python chess and engines such as Stockfish are freely available and so easy to work with. In that vein, I've uploaded the source for this project onto my GitHub page. Now all that's left is for me to learn how to play chess.